The Piri Reis map, 1929. In 1929, historians were cleaning out the dusty shells of the Topkapi Palace in Istanbul when they found a gazelle-skin parchment that shouldn't exist. It was signed by an Ottoman admiral named Piri Reis, dated to the Islamic year 919, 1513 AD. At first glance, it looks like a standard Portolan chart of the time, beautiful, colorful, and reasonably accurate regarding the coast of Brazil. But when you look south of South America, the logic of history breaks. The map shows a coastline running eastward from the tip of South America. For decades, skeptics called this a creative filler, just an artist running out of paper and bending the coast of Argentina. But in the 1960s, Captain Arlington H. Mallory, a cartographer for the U.S. Navy, took the Piri Reis map and subjected it to a grid analysis. He found that if you project the map using a specific spherical trigonometry, equidistant projection centered on Cairo, the bent coastline straightens out perfectly, and it matches the coastline of Queen Maud Land in Antarctica. Here is the problem. Queen Maud Land is currently buried under a mile of solid ice. We didn't even know that coastline existed until the Swedish-British-Norwegian seismic expedition of 1949. Piri Reis drew it in 1513. But the anomaly goes deeper. The Piri Reis map doesn't just show the coast, it shows topographical details, bays, islands, and river mouths that are currently invisible to the naked eye. In 2025, the release of the BedMap 3 sub-glacial scan data finally gave us a high-resolution look at the bedrock beneath the Antarctic ice sheet. When you overlay the Piri Reis coastline onto the 2025 BedMap data, the correlation coefficient is terrifying. The map shows a specific bay where the Juttelstraumen Glacier now sits. It shows islands that are currently inland mountains, buried up to their peaks in ice. Piri Reis himself wrote a note in the margins of the map. He didn't claim to explore this land. He admitted he was a compiler. He wrote that he used 20 older source maps, including 8 Ptolemaic maps and maps from the Sea of the Indies that dated back to the time of Alexander the Great. This is the smoking gun. Piri Reis wasn't a psychic. He was a librarian. He was copying data from a source that had mapped Antarctica before the ice sheet formed. The science of glaciology tells us the last time Queen Maud Land was free of ice was at least 6,000 years ago, and likely much longer. This implies that a civilization with the mathematical capability to calculate longitude, something Europe couldn't do until the 1700s, and the maritime capability to survey a polar continent existed in deep antiquity. The Piri Reis map isn't a medieval discovery. It is a copy of a document from a lost global survey. It is evidence that we are living in a post-apocalyptic world, and our discovery of Antarctica was actually a rediscovery. The Oronteus Finaeus map, 1531. 18 years after Piri Reis, a French mathematician named Oronteus Finaeus published a world map that makes the Piri Reis anomaly look like a rounding error. While Piri Reis showed a fragment of the Antarctic coast, Finaeus drew the entire continent. The Oronteus Finaeus map depicts Terra Australis not as a vague theoretical blob, but as a defined landmass with complex geography. It shows mountain ranges, river valleys, and distinct bays. For centuries, this was dismissed as a lucky guess, but look closer at the Ross Sea. Today, the Ross Sea is dominated by the Ross Ice Shelf, a floating slab of ice the size of France, hundreds of feet thick. It creates a massive flat barrier that prevents ships from reaching the true coastline. On the Finaeus map, there is no ice shelf. Instead, there is an open estuary. The map shows wide river mouths flowing from the interior mountains into the open sea. In 1949, the Byrd Antarctic expedition took core samples from the bottom of the Ross Sea. They drilled through the ice shelf and into the seabed. The layers of sediment they found told a story that geology is still struggling to accept. They found layers of fine-grained sediment, the kind that is carried by flowing rivers. They found no evidence of glacial scouring in those specific layers. This proves that at some point in the geologically recent past, the Ross Sea was open water and the Antarctic interior was warm enough to support liquid rivers. The Finaeus map places these rivers exactly where the sub-glacial scans show deep valleys today. If you strip the ice off the transantarctic mountains, the drainage basins align perfectly with the river systems Finaeus drew in 1531. How did a French mathematician in the 16th century know the location of river valleys that have been frozen solid for millennia? The official narrative is that he was guessing based on the theory of balancing land masses. But you don't guess the correct latitude of the Beardmore Glacier Valley. You don't guess the shape of the Muglik-Hoffman Mountains. The implications of the Finaeus map are disturbing because of the timeline. If the rivers were flowing, the climate of Antarctica must have been temperate. This pushes the ice-free window to a period that coincides with the end of the last ice age, around 10,000 to 12,000 years ago. This aligns with the younger Dryas boundary, a period of cataclysmic climate shift. The map suggests that before the freeze, someone was there. Someone was mapping the river deltas. They weren't just sailing past, they were surveying the interior. The Oronteus Finaeus map is a snapshot of the world right before the thermostat broke.
The Buache Dataset, 1739. In 1739, Philippe Buache, a French geographer known for his rigorous attention to detail, published a map that seemingly violates the laws of physics. His map of Antarctica is titled Carte des Terres Australes. At first glance, it looks like another depiction of the southern continent. But look at the center. Buache depicts Antarctica not as a single solid continent, but as two large islands separated by a massive waterway running through the middle. He shows a frozen sea, or mer glaciale, dividing the landmass in two. For 200 years, geographers laughed at this. Everyone knew Antarctica was a solid block of land covered in ice. Buache was dismissed as a fantasist who was trying to justify his theories about inland seas. Then came the International Geophysical Year of 1958. Scientists used advanced seismic sounding equipment to map the sub-glacial topography of Antarctica for the first time in modern history. The results were shocking. The seismic data revealed that Antarctica is not a single continent. It is an archipelago. If you remove the ice, the bedrock is split into two primary landmasses, East Antarctica and West Antarctica, separated by a deep subsea trench that connects the Ross Sea to the Weddell Sea. Philippe Buache drew this separation in 1739. There is no way to know this from the surface. The ice sheet bridges the gap completely. The ice over that trench is kilometers thick. You cannot see the archipelago with the naked eye. You cannot see it from a ship, and you cannot see it from a plane. You can only see it with seismic equipment, or if you saw it before the ice was there. The Buache map is arguably the most impossible of the entire collection because it depicts the bedrock topography. Piri Reis and Finaeus showed coastlines and rivers, features that could conceivably be seen during a warm period, but the channel separating East and West Antarctica would have been underwater even during a warm period, or it would have been a massive strait. Buache labels it accurately. The precision is unnerving. He places the cut exactly where the Transantarctic Mountains separate from the Ellsworth Mountains. The sheer statistical impossibility of guessing the subglacial archipelago structure correctly is near zero. This forces us to ask, what was the Buache dataset? He was a member of the French Academy of Sciences. He had access to the Royal Library. Like Piri Reis, he was working from source maps that have since been lost or locked away. The Buache map implies that the ancient cartographers didn't just sail around the coast, they understood the tectonic structure of the land. It suggests a level of geological awareness that matches our 2025 capabilities. We are looking at a map drawn by a civilization that treated the planet as a single, manageable asset. The Hadji Ahmed map, 1559. In 1559, a Tunisian cartographer named Hadji Ahmed created a cordiform, heart-shaped map of the world for the Ottoman Empire. By this time, the Americas had been discovered and maps were becoming more modern. But Ahmed's map contains a glaring anomaly in the North Pacific. He depicts a massive land bridge connecting Siberia and Alaska. This isn't just a thin strip of ice, it is a wide, habitable causeway, roughly 1,000 miles across. We know today that this land bridge, Beringia, actually existed. During the last ice age, sea levels were roughly 400 feet lower than they are today because so much water was locked up in the glacial ice sheets. This exposed the continental shelf connecting Asia and North America. Humans and megafauna walked across this bridge to populate the Americas. But here is the glitch. Beringia was submerged by rising sea levels around 10,000 BC. By 1559 AD, when Hadji Ahmed drew his map, that land bridge had been underwater for over 11,000 years. There is no explanation for this. No Renaissance sailor could have mapped Beringia. It was 50 meters underwater. The only way Hadji Ahmed could draw that land bridge is if he was copying a source map that was drawn during the Ice Age. This map completely rewrites the Stone Age narrative. We are taught that humans 12,000 years ago were hunter-gatherers with flint spears. Yet someone at that time had the technology to perform a cartographic survey of the Northern Hemisphere that was accurate enough to be preserved for 11 millennia. The Hadji Ahmed map also shows a highly accurate, ice-free coast of Antarctica, corroborating the Piri Reis and Finaeus data. It presents a coherent picture of the world as it looked around 12,000 BC. Lower sea levels in the north, habitable land bridges, and a temperate Antarctica in the south. This suggests that the Great Reset wasn't just a myth. The map preserves the geography of the antediluvian world, the world before the flood. When the ice caps melted or shifted, sea levels rose, Beringia drowned, and Antarctica froze. The civilization that mapped it was destroyed, but their data survived, copied by generation after generation of cartographers who didn't understand what they were drawing. Hadji Ahmed thought he was drawing the world of 1559. In reality, he was drawing a memorial to a lost epoch.
The Zeno map, 1380-1558. In 1558, a Venetian named Niccolo Zeno published a map that he claimed was discovered in his family's attic. He said it was drawn by his ancestors, the Zeno brothers, who voyaged to the North Atlantic in the 1380s, a full century before Columbus. The map shows Greenland, Iceland, and the coast of Norway, but it also shows islands that simply do not exist today. The most famous is Friesland, a large, detailed island south of Iceland. It also shows Estotaland and Icaria. For centuries, this was dismissed as a hoax or a navigational error, ghost islands invented to secure Venetian bragging rights. But in the age of deep-sea sonar, the Zeno map has become a terrifying puzzle. When we map the floor of the North Atlantic today, we find the Faroe Bank and other submerged plateaus. If you lower the sea level or raise the seabed, the topography of these underwater banks matches the shape of Friesland on the Zeno map. This brings us to the geological concept of isostatic rebound and subsidence. The North Atlantic is a highly active volcanic region. Islands can rise and sink. But for an island the size of Friesland to sink entirely requires a cataclysm or a timeline that stretches back far beyond the 1380s. Some geologists suggest that the Zeno map, like the others, is a copy of a much older source. It depicts the North Atlantic not as it was in the 14th century, but as it was during the period of lower sea levels or different tectonic activity. The Zeno map also accurately depicts the longitude of Greenland, a feat that was technically impossible in the 1380s. The map places sites in Greenland at their correct absolute locations, not just relative sailing days. This implies the use of a chronometer or celestial navigation system far superior to anything medieval Europe possessed. If the Zeno brothers actually visited these places in 1380, they were using maps that were already thousands of years old, maps that showed islands that were already sinking beneath the waves. The ghost islands of the North Atlantic aren't errors, they're memories. They're the high ground of a drowned world. The Zeno map is evidence that the Atlantic Ocean was once a much more crowded place, a maritime highway with stepping stones that have since been deleted by the ocean. The Kangnido map, 1402. In 1402, decades before European explorers rounded the Cape of Good Hope, Korean imperial cartographers produced the Kangnido Yokdai Gukdo Jido, the map of integrated lands. It is a masterpiece of Asian cartography. It focuses on China and Korea, which are enlarged to reflect their importance. But if you look to the west, you see Africa. Europeans in 1402 had no idea what the shape of Africa was. They thought it might extend indefinitely to the south or turn west to connect with Asia. But the Kangnido map shows the correct triangular shape of the African continent. It shows the tip of South Africa. It shows the lighthouse of Alexandria. But the most impossible detail is in the interior. The Kangnido map depicts the source of the Nile River. It shows the river flowing from great lakes in the southern half of the continent. Europeans wouldn't discover Lake Victoria and the source of the Nile until the mid-19th century, 450 years later. How did Korean scholars in 1402 know the geography of the African interior? The official explanation is that they obtained information from Islamic geographers, who in turn got it from whom? The Romans? The Greeks? None of them explored the deep interior of sub-Saharan Africa. The Kangnido map implies a global trade network that predates our history books. It suggests that knowledge traveled freely from South Africa to East Asia long before the Age of Discovery. The accuracy of the African coastlines and the internal river systems suggests that the Indian Ocean was an Ottoman lake, or perhaps something even older, a maritime zone controlled by a civilization that treated the distance between Korea and South Africa as a standard trade route. The map acts as a data link. It proves that the East and West were not isolated. The data on this map had to come from a source that had surveyed the entire Old World. It breaks the Eurocentric model of exploration. We didn't fill in the blanks of the map. We slowly recovered pieces of a puzzle that had been solved thousands of years ago. The Kangnido is a backup file of a global database that crashed.
The Mauro charts, often associated with the voyages of Admiral Zhang He in the early 1400s, is usually presented as a standard navigational chart. But when you analyze the mathematical projection, it reveals a technology that shouldn't exist. The map doesn't use the grid system we are familiar with, latitude and longitude. Instead, it uses a schematic, star-based navigation system. It tells the navigator exactly which star to look at what angle above the horizon, to determine their location. This is celestial navigation at an elite level. But the anomaly is in the precision. The Mauro charts cover a massive area, from Nanjing to the coast of East Africa. The relative positions of the ports, islands, and reefs are astoundingly accurate, but they are distorted in a way that implies projective geometry. In the 1970s, mathematicians realized that the distortions in these Chinese maps weren't errors, they were features. The map is designed to be viewed from a specific perspective, a God's eye view from a satellite-like altitude projected onto a scrolling strip. Some researchers argue that the trigonometric calculations required to produce the Mauro charts, specifically the longitude calculations across the open Indian Ocean, require knowledge of spherical geometry that wasn't formally developed until centuries later. Furthermore, the charts show details of the East African coast that Zhang He's fleet supposedly visited only briefly. They mark reefs and shoals that would require a hydrographic survey, years of sounding and measuring, not just a passing visit. This suggests that Zhang He wasn't discovering these routes, he was patrolling them. He was using charts that were inherited from previous dynasties. The impossible geometry of the Mauro charts points to a legacy of high-tech navigation in the East that parallels the Piri Reis mystery in the West. It reinforces the idea of a global maritime civilization that shared a common mathematical language of the stars, a language we have only recently relearned with GPS. The Vinland map, the node. The Vinland map is perhaps the most controversial document in cartographic history. Surfacing in the 1950s, it purports to be a 15th century map showing Vinland, the Norse name for North America. For years, the debate has focused on the ink. Is it modern titanium ink? Is it medieval iron gal? In 2021, a study claimed it was a fake. But other independent researchers argue that chemical composition is consistent with medieval production techniques that use titaniferous sand. The debate distracts from the geography. Look at the depiction of Vinland. It doesn't look like the messy, vague descriptions in the Viking sagas. It looks like a map. It shows the three distinct landmasses corresponding to Baffin Island, Helluland, Labrador, Markland, and Newfoundland, Vinland. It shows the inlet of the St. Lawrence River. But the odd why is how it frames North America. It doesn't show it as a new world. It shows it as a node in the North Atlantic network. It sits casually on the left side of the map, balanced by Greenland and Iceland. If the map is genuine, or if it is a copy of genuine Norse data, it completely destroys the Columbus narrative. It proves that the Norse didn't just accidentally hit America. They mapped it. They understood its relationship to Greenland. The Vinland on the map isn't a mythical land of grapes. It's a navigational waypoint. But look at the inscription. It mentions the Bishop Eric who went to Vinland in 1117. This implies an administrative connection. You don't send a bishop to a temporary camp. You send a bishop to a diocese. This map suggests that North America was part of the European administrative grid in the 12th century. It was a known quantity. The Vinland map, regardless of the ink controversy, represents a mental map that existed in the North. It shows that the Atlantic was crossed regularly. The discovery of America in 1492 was actually a corporate takeover of a route that the Northern Europeans had been keeping quiet for centuries.
The map shows the world as a connected system, where the Atlantic was a bridge, not a barrier. The Fra Mauro map, 1450. Fra Mauro was a monk in Venice who created the most detailed map of the medieval world in 1450. It is a massive circular planisphere, crammed with thousands of annotations. But the first thing you notice is that it is upside down. South is at the top. Why? The standard answer is that Islamic maps put south at the top, and Fra Mauro was influenced by Arab cartographers. But there is a deeper logic here. In a southern hemisphere dominant civilization, south is up. If the source maps for ancient knowledge came from a civilization that navigated the southern oceans, the global maritime kings we've been tracking, then south up is the correct orientation. Fra Mauro's map is famous for its rejection of religious dogma in favor of empirical evidence. He dismisses the idea that Jerusalem is the center of the world, but look at what he puts at the top, the south. He depicts the Indian Ocean not as an enclosed lake, as Ptolemy did, but as an open ocean connected to the Atlantic. He shows ships sailing around the southern tip of Africa decades before Diaz or da Gama did it. He writes in the margins that he spoke with travelers who had sailed from the Sea of India into the Sea of Darkness, the Atlantic. This confirms the Kangnido data. The trade route around Africa was open and known. But the most bizarre detail is a small island in the far south, labeled with a text that speaks of dragons and 7 cities. Some researchers argue this is a distorted memory of South America or Antarctica. Fra Mauro was trying to reconcile the ancient data with the reports of his time. The upside-down orientation forces us to look at the world differently. It highlights the Indian Ocean as the center of gravity for the ancient world. The Mediterranean, the focus of our history, is just a sideshow in the top corner. The real action, the real trade, and the real source of the data was in the south. Fra Mauro's map is a transitional fossil. It's a medieval monk trying to parse the data of a lost super-civilization and deciding that the south was the direction that mattered most.
The 2025 satellite audit, the recovery. In 2025, the game changed. We launched the next generation of gravimetric and lidar satellites, specifically designed to audit the polar regions and the deep ocean floor. The goal was to monitor climate change. The result was a historical crisis. The 2025 data didn't just give us ice thickness, it gave us a sub-glacial digital elevation model of unprecedented resolution. We can now see the rivers, the canyons, and the volcanoes beneath the Antarctic ice as clearly as we see the Grand Canyon. And this is where the impossible maps stop being curiosities and start being evidence. When we run the Piri Reis projection algorithm on the 2025 data, the error margin drops to less than 2%. The bays match, the islands match, the rivers on the Oronteus Finaeus map line up with the sub-glacial hydrological channels identified by the 2025 satellites. The Archipelago cut of the Buache map matches the Rift Valley seismic scans perfectly. This is a statistical impossibility. You cannot get 3 different maps from 3 different centuries drawn by 3 different men to all align with a 2025 satellite scan of a buried continent by accident. The conclusion is uncomfortable but unavoidable. Our current maps, Google Earth, the Mercator projection, the satellite scans, are not the first time this planet has been surveyed. They are the second time. We are looking at recovery documents. The Piri Reis map is a low-resolution JPEG of a high-resolution original. The Oronteus Finaeus map is a corrupted file that preserved the river data. The Buache map is a tectonic schematic that survived the formatting wipe. The 2025 audit proves that a global, maritime, technologically advanced civilization existed during the last ice age. They had the math to calculate longitude. They had the ships to survey the poles. They had the stability to maintain records for thousands of years. And then something happened. The ice shifted, the crust moved, the water rose, and the lights went out. We spent the last 5,000 years crawling back out of the mud, reinventing the wheel, and drawing clumsy maps of the world thinking we were the first. But the 2025 scans show us the truth. We are walking in the footsteps of giants who mapped the world before the ice erased it. The question isn't how did they know? The question is what happened to them? And more importantly, is it about to happen to us?